keep on forgetting this. Okay, so now let me just have a look at the different kind of main concept that you need to remember. So that main concept, this is the main concept you need to remember in this chapter. If you have a power function y is equal to a raised to x raised to n, your x is in the base. There are two possibilities. X is in the base in the power function, and in exponential function, x is in the power. You take log on both the sides. You can take ln also on both the sides, doesn't matter. Correct? If you take logs on both the sides and expand it, log y is equal to log a plus n log x. Correct? So you arrange it. So this is your y is equal to mx plus c. Correct? So on your y-axis there's a log y. Yeah. On your x-axis there's a log x. So this is, you get your log graph. Yeah. If you have an exponential function, y is equal to ab raised to x. Your x is in the power. So whenever you have an exponential function, you'll get a semi-log graph. When you have a power function, you'll get a log graph. Remember that. Because x won't be log. Yeah. Correct. So if I take logs on both the sides, log y is equal to log a plus x log b. So if you rearrange, log y is equal to log b. Now remember, log b is a number. Yeah, b is so it's a constant. X, yeah, so it's a constant. So you'll get a semi-log graph. Semi-log graph is one in which you're on the x-axis, you have x, and on the y-axis you have log. Do we have to know rough sketches for this? Yeah, there's a straight line. It will be a straight line. No, all these are straight line graphs. What's the difference? Both are straight line graphs. Yeah. Only the axes are different. Both the lines would be a straight line graph. Only this is a straight line graph. The y-intercept will be, both will be straight line graph. To linearize any power exponential function, ln or log can be used. It will not matter. Yeah. If graphs of log and semi-log graphs are given, to decide which model to use, they'll give you two graphs. They'll give you a semi-log graph and they'll give you a log graph, and they'll say, okay, find a model. Yeah. To decide which model, choose and use the graph with a straight line. So out of the two graphs, whichever is having the straight line, use that. So you just put both the graphs. So if log graph is a straight line, then the model is a power function. Yeah. If semi-log graph is a straight line, the model is exponential. Yeah. And the other graph you ignore the non-straight graph. So we'll be seeing those examples over here. That comes later. So now it begins with linearizing. Here you simply take log on both the sides. Yeah. Correct? In each of the sums you take log on both the sides. Correct? Y is equal to mx plus c, and it is a straight line, and since the y-intercept is 0, straight line passing to the origin. Yeah. Okay. So when you linearize, you'll get a log function for power function. Your exponential will give you what? All these exponential functions, whenever x in the power, you'll always get a semi-log graph. Now in this case, you'll take ln on both the sides. Why will you take ln on both the sides? Because ln is equal to 1. Yeah. Whenever there's an e, you should take ln on both the sides. Whenever there's e. Now see, this is the question they're asking you. The graph below shows a log graph. Yeah. Okay. Use this to suggest a relationship between x and y. Now this is a log graph. So it's a straight line graph. It's a straight line graph. Which means it's ax. Correct. So you find the you take any 2 points, find the slope. Yeah. Find the slope of the line. You know the y-intercept. The y-intercept is given to you. So use y is equal to mx plus c. But your y-axis is having log y. So replace this as log y. Correct? Your x is having log x. Yeah. Okay, and then you substitute. Yeah. You just combine it. This is one way of doing it. The other way of doing it is, there are two methods of doing it. What I showed you in the previous video, which previous thing is using method 1. You can also use method 2. Method 2, what do you say? Since it's log graph, it's a power function. Since it's a log graph, it's a power function. So let y is equal to ax raised to n. You take logs on both the sides. So log y is equal to log a plus n log x. Yeah. Correct? This will be your y-intercept. Correct? So log a, you look at the y-intercept over here. So log a is equal to this. So a is equal to 10 raised to this. You round it off to one significant figure. The textbook is rounded off. But actually in IB you have to write to 3 significant figures. The IB, this textbook is writing this as 6. Therefore I wrote as 6. This will be the slope of the line. So how do you find slope of the line? Take 2 points and find the slope. Yeah. Correct? Slope is equal to this. So this is your n. N is equal to 3.92. So your n is equal to 4. Put it back. Yeah. So your a is 6. Put it back over here. And your n is 4. Put it back over here. This is method 2 of doing it. Now the method 1 that I showed you, we got this. If you round these values, you'll get same answer. 6x raised to 4. The textbook is rounded off. So either you find the equation of a line and then combine it, or you start with this and then find a y-intercept and slope. Both are fine. Now 10th one, same way. It's a log graph. If it's a log graph, it's an exponential function. Take logs on both the sides. Log y is equal to log a plus n log x. So this is your y-intercept. So you see what's your y-intercept. This is your y-intercept. Correct? This is slope. So slope you find out. Use that to find your n and your y-intercept, and you'll get your answer. Yeah. So I've shown you in this using both those methods. Correct? Now, see, this is the sum I'm talking about. Important. Yeah. The scatter plots below show a semi-log graph. Semi-log graph is, this is your semi-log graph. Yeah. And log plot for a set of data. Use the plots to suggest the relationship between x and y. Give the values of any parameters to one significant figure. The relationship will be found. So which one will you take? Exponential. Why will you take exponential? Because that's a straight line. Yeah. So you check it, these two lines. Whichever gives you a straight line, you take that. Yeah. So I'll take this as my reference. Yeah. Now this is a semi-log graph. A semi-log graph will be what? A semi-log graph will be exponential. So let it be y is equal to ab raised to x. Yeah. So ln y is equal to ln a plus x ln b. So ln a is the y-intercept. So you see the y-intercept. Now this sum is not very clear. In IB, if they give you this sum, they'll give you clear points. Yeah. And for this, you find a slope. Now I have approximately done it over here. But this will be better sum. I mean, the numbers will be better. But the idea is important. 14. How do you do this? Now reverse. They is given you a table of values. The amount of radioactive substance x grams at time t minutes after it's created is modeled by x is equal to x naught e raised to minus kt. So what kind of model is this? Is it power or exponential? So this will be, that's the et, na? So this is your power, exponential. Exponential, I mean. T is in the power, no? So exponential model. A b raised to x. That's a b raised to x. Yes, so b is power. Yeah, so this is the exponential. So exponential model will be a semi-log graph. Correct? So linearize the relationship. So linearize the relation. How do you take ln on both the sides because there's e. So x is equal to x naught e raised to minus kt. Take ln on both the sides. Expand it ln x naught plus ln e raised to minus kt. This minus kt comes in front. Minus kt ln e. What is value of ln e? 1. So this is your. So that means if I am plotting this line, this is what I need to look at. Correct? This is your linearize the relation. This is your part A answer. The following measurements are taken. T and x. Use linear regression to estimate x naught and k. This x naught and k is to be found. So now I look at this. I have to take ln of x. They have given me x. You have to take ln of x. So you take ln of x. And your t you keep it as it is. You put this in list 1. You put this in list 2 in your calculator. You put this in, you put your, what will you put in list 1? T. And list 2 ln x. So you can keep that as list 3. And when you can also take in list 3. Yeah. You can directly put ln x. Ln of the second list. L2. You adjusted 2 variable list when you adjusted. You'll get a slope and the y-intercept. So so the slope would be minus k. So you compare. So your minus k is this. So k is equal to this. So this is your k. And your ln x naught is this. ln x naught is this. So your x naught will be e raised to that, and that's your this. And therefore that's how your model becomes. Important, someone? This is very, very important. Okay. Use your model to estimate the time taken for the amount of substance to halve. So that means you take your original value is x naught. This is your original. When dot t is equal to 0 as x naught. Your x will be x naught over 2. Cancels off. So half is equal to. You can use solvent. Yeah. If you don't want to, just use solvent. If you don't want to take ln on both, use solvent and you'll get the value of t. So, you know, what you need to remember is, you have to remember that the main Guru Mantra. Exponential. Power gives you what? Log graph. And exponential gives you semi-log. Bas. That's the whole thing you need to remember. Now in this case, look at this. Is this power or exponential? Now see, you think like this. They've given you d, which is a variable, which is in the base. And they give you f. So remember, when they give you like this, you think like this is your x and this is your y. Yeah. So your x in the base or is the x in the base or in the power? So it's in the base. Base. So that will be a log. Log. Yeah. Linearize the relations. You take logs on both the sides. I've taken ln on both the sides. Yeah. It doesn't matter. Correct? So now you know it's a log. Because it's a power, it's a log. Yeah. So that means. So b is equal to ln k and a. So now they say find k and n. So what will you do? This is your list 1. What will you do in this? List 2. Then list 3. List 3 will be what? LND. Yeah, list 3 in your calculator when you do, you'll do LND. List 4 you'll do LNF. And then you do linear regression on list 3 and list 4. And your A will give you -2. Your A is your y-intercept. So your A is a slope, I mean. So in this case, the slope is n. Yes. Correct? Your slope is n. And your y-intercept is ln k. So this, your calculator gives you this value. That's your ln k.